with their presentation. So what we're going to do first of all is we're going to talk about in the agenda, we're going to talk about the regulatory aspects of the business, what's going on, the 3 through 25 ton business, and then the commercial system solution, your blueprint to win out there in the marketplace. From a regulatory standpoint, we're going to look at the constant volume package equipment. We're going to talk about the R22 transition, refrigerant transition, the federal minimum efficiency requirements, and then we're going to talk about the higher tier efficiency guidelines and standards in 2010 and going into the future. So first of all, when we're talking about the R22 transition, as everybody probably knows, R22 packaged products are no longer produced by manufacturers. So they could no longer produce products from December 31st, 2009, and all R22 units that are in stock and produced before December 31st, 2009 can be sold and installed on projects. So there's not an issue with us having it in stock and then selling the products itself to the contractors and the owners. TEC itself has many R22 rooftops in stock and also condensing units in stock. First of all, on the condensing unit size, we have 1.5 to 5 ton residential style condensing units, and from the commercial condensing unit sizes from 6 to 20 tons. I think actually 25 tons we have in stock right now on R22. The supplies are not there. We have a lot of the residential style units, but the commercial style units, there's not a lot left. The key thing you have to understand when we're doing condensing unit changes with R22, you can't just take an R-410a condensing unit and place it in an old R22 condensing unit spot. So what you're going to, key thing is you may have to change the line sets. You're going to probably have to change the coil. You're definitely going to have to change the TXVs for the system itself. So the key thing, if you can actually replace a new unit, an old unit with an R22 condensing unit right now in the short term, it probably makes a lot of sense from the end user standpoint, so they don't have to change out all those other pieces in the system, the TXV, the coils, and possibly the line set in the system itself. The other piece here we want to talk about is the fact that basically Carrier has, from 25 tons plus, is still producing a nitrogen charge large tonnage condensing unit from 25 tons to 120 tons. And it's basically used for replacement opportunities only. The replacement opportunity will probably not last long because it's kind of a loophole in the EPA guideline. So what we're doing at this point, we're still producing that R22 condensing, but we're shipping it out with a nitrogen charge for R22 replacements only. I imagine that's not going to last long. So if you have a customer with an old condensing unit out there that basically is on its last leg, it may be a good idea to replace that unit at this time in this year. Okay. I'm sorry, I'm looking at the, okay, here I'm just looking at the questions real quick. The second thing on the refrigerant transition, as most people know, is that we've gone to the R-410a Puron refrigerant, and that whole line was converted on our base tier line unit Q4 of 2009 on split systems, condensing units, rooftops across the board. So we have a complete line of R-410a rooftop units in the marketplace right now. So from an efficiency standpoint, what we have is we have the federal government, the federal government develops, I'm sorry, let me just, there we go. The federal government develops the levels for NAECA, which is the National Appliance Energy Conservation Act and an Energy Policy Act. So 5 tons and below, basically that that piece of that equipment and below was changed in 2007, if everybody remembers, up to 13 SEER. That has not changed at all. It is still at 13 SEER. In 2010. The thing that you have seen that is changed is 6 to 63 tons. And the federal government, the DOE, approves the ASHRAE 90.1 minimum efficiency levels via the Energy Policy Act which basically now goes up to 63 tons. So now all the companies now that produce rooftops have to meet the certain ASHRAE guidelines up to 63 tons, where they didn't have to do it up to 63 tons in the past. When you look at the comparison from 2009 and 2010, what has impacted this package rooftop market? If you look here on the top part of it, which says package gas, which is the GE, which is gas electric, 6 to 10 tons. Now, when you start talking about increasing stuff by 10%, there's an awful lot of engineering that has to go into that to increase those efficiencies up to that high. What we did is in 2009, our base tier equipment was 10.1 EER. And now in 2010, it is 11 EER. That's a 9% increase. 12.5 to 20 tons, we went from 9.5 EER to 10.8 EER, which was the largest jump, a 14% increase. And then 20 tons plus went from 9.3 to 9.8, which was a 5% increase. And you can see down the line, basically, it's a similar story for electric, package heat pumps, split air condensing units, and heat pumps also. From what you're looking at, this kind of gives you a further illustration of it. Basically, where we were at ASHRAE 2007, where we're at ASHRAE 2010, and this is our base entry line unit, which is our 48TC unit we have in the marketplace, and you can see that basically it exceeds obviously all 2007 levels, and it's going to be basically now our base tier entry level in 2010, which I'll go into greater detail later on here. The other key piece we're looking at is there's a new part load matrix metric called IEER. IEER stands for Integrated Energy Efficiency Ratio, and this basically allows us to do a better part load performance model on the rooftops itself. IEER does a better job of reflecting the indoor fan operation, the ambient variation in different areas, and it's more beneficial to the part load performance improvement. So if you look here in the slide, you have basically a 10-ton unit, the 48TCD. Last year, we rated it an IPLV, and it was 12.2 IPLV. This year, we're rating it an IEER, Integrated Energy Efficiency Ratio, and it's now 11.8. So when you're comparing energy efficiency, basically energy on rooftops, the key piece is you have to make sure you're comparing. If you're comparing IPLV, make sure the other one has IPLV. If you're comparing IER, which I would compare everything on IER now, you have to compare it all to IER, because if you're comparing someone's IER to someone's IPLV, you could see there the guy who's measured on IPLV has a slight advantage. So in 15 tons, it's the same story. The IER is slightly less than the IPLV, the old model. So with ASHRAE 90.1, what's next? We kind of discussed the 2010 minimum efficiency standards up to 63 tons. IEER part load metric replaces IPLV. Exhaust air energy recovery scope, which is mandated. And we'll discuss this in the product part later on here, and I have a couple slides after that to show you a little bit of the matrix on what they're looking at in section 6.5.61 addendum E in a second, and I'll address that one. The other key piece is manual dampers are not allowed. 2010 from a federal standpoint, and I believe in the statewide, it's going to be adopted mid-year. What we have coming up and what you're going to be seeing moving into the future is January 2011, we're going to have higher indoor motor efficiencies greater than 1 horsepower. Low leakage damper, economizer dampers, 2012. This is really driven from a lot from the California, from California itself is coming out here. They have a very strict policy on their economizers and making sure they're properly commissioned and working properly. Right now out in California, every economizer has to be commissioned properly that is installed in California, which you could see could cost a lot of dollars for end users, which we see that possibly coming in obviously into the Midwest probably in the future. So The other key thing in 2012 is the two-speed fan requirements for single-zone systems. We'll show you our variable speed system later on here today, which will show you really the true benefits of having a two-speed fan requirement on the single-zone system. It's a huge payback. And then they basically in 2012 they're going to go into the multiple VAV control changes, reheat, DDC, and dehumidification part of it also. So ASHRAE 90.1 Section 6 changes, we mentioned there previously, no manual outside air dampers, and we basically start seeing this implemented mid-2010 by state. So it prohibits the use of fixed manual outside air dampers, and you can use two-position minimum dampers as a minimum. Now, at that point, you're buying a two-position damper as a minimum. The price difference between a two-position damper and economizer is so little, I would never recommend anybody putting a two-position damper in versus an economizer. At that point, I would just put an economizer in. You'd see paybacks, especially in the Chicago climate, right away. Let me just see if we have any questions here. I don't think we have any questions at this. Whoop, I'm sorry, we have questions here. Okay, I think we're all set here. Okay, so that's where we're at with the economizer part of it. From future efficiency, what you're going to see happening from a single phase part, 5 tons and under, is they're going to rate things by climate zone. So you're going to have a northern climate zone, a southern climate zone, and a southwest climate zone, and they're going to rate it by heating degree days. So here in the northern climate, we have over 5,000 hours of heating degree days. In the southern climate, they have less than 5,000 hour heating degree days. So you're going to see different efficiencies for different climate zones, who basically have more hours in the cooling end of it, and less hours in the cooling end of it. We spoke about the energy recovery part of it, and if you look here, the way that it's broken out in this chart, we would be in the green section, which would be 5. It would be basically under the moist 5A category is where we would be at in Chicagoland area. And from this chart, from the energy recovery chart here, our 5A category, basically we're in anything that delivers outside air at full. So basically what we're looking at is 30% outside air on a system, 5,500 CFM and above. You are going to require energy recovery on it, and that from a payback standpoint, energy recovery is just such a great investment. You basically see your rate of return fairly quickly. At this point right now, I see that as being one of your best investments as an end user can make at this time. And if anybody has any questions on energy recovery, you can email me. We can set up a presentation for your office, and we can show you how to do that payback analysis if you're interested in doing that. Now we're going to talk a little bit about the higher tier efficiency guidelines and standards. Higher tier standards and guidelines. Now, that's been a theme out in the marketplace for many years now, basically talking about energy savings, indoor air quality, and energy use resources like sustainable design. So you'll see the key things in here like LEED, and some of the things that you're going to see that you probably may not be aware of, which is this CEE, this Consortium of Energy Efficiency, and manufacturers are now rating their equipment to this consortium of energy efficiency standards now. They have a Tier 1 and a Tier 2 standard. So you have the guidelines there, and basically what I would recommend, if you have any questions on these standard and guidelines, you could always go to carrier.com for up-to-date minutes, up-to-date to the minute standards from our end of it, what we see. But this is kind of what we are looking at as a manufacturer right now. You have multiple categories of subcategories. So we have ASHRAE 90.1 2010, we have CEE Tier 1, we have ENERGY Star 510, we have ASHRAE 189, and we have CEE Tier 2. And if you look at the chart, the size is obviously in BTUs, so 65,000 tons and 65,000 BTUs and under. It's greater than 65,000. It's basically up to about 10 tons, and you can see the different efficiencies we have to meet. So That ASHRAE 90.1 2010, where we have a 13 SEER, that did not change from where we're at previously. And the pieces that have changed was the 65, 136, and on down is what has changed. And really, from a manufacturer standpoint, we're looking at two of these categories. We're looking at the ASHRAE 90.1 2010, the minimum efficiency point into the marketplace, which is probably where 80 to 90% of the equipment is bought. And then we're looking at this CEE Tier 2 part, which is where we feel that most of the rebates are going to be coming from. So if your equipment meets CEE Tier 2, that is where you're going to see most of those rebates going. And from a manufacturer, it doesn't give you any really benefit to make a unit more efficient than that CE Tier 2, because at that point you're investing in something, you know, you don't see a lot of payback at that point from that end of it. So that's from the manufacturer. I'd love to see it basically make more and more efficient as we move forward, but you're not going to see a manufacturer producing much higher than that CE Tier 2 until different, you know, basically standards are out there. So from what we're looking at here, we have our base. This is the CEE Tier 2 part, which is the green line right here. And then we have the Energy Star CEE Tier 1 line right here. So you see those two lines. From our product standpoint, and we have it called our Centurion and our Weathermaster, and you'll be able to see that later on. The Centurion is our 48 PG/PM style unit, and our Weathermaster is our 48 HC, our new high efficiency tier unit that we have in the market. What you're seeing here is we are set up very nicely up to 25 tons going out with the product line of basically being at or above CEE Tier 2 across the whole line of products. So with our 48HC, we are at or above the minimum line of 15 SEER, 15 EER. And then 6 to 10 tons, we are at or the one product where we are actually below it. We only meet Energy Star CE Tier 1, which is our 10-ton HC unit. We actually meet it with our PG style Centurion style unit. And then 11 to 20 tons, you see we are at or above. Actually, we meet it across the board, and then 20 tons plus, we meet it. So from a manufacturer standpoint, we basically meet that whole criteria. So we're going to talk about basically new packaged products. So the business opportunity that we see out there right now, which is actually out there, is we have a 2.9 million installed base of Carrier Bryant rooftops in the marketplace. And 75% of the marketplace at this point is all replacement. So your advantage basically from a contractor engineer is that we basically fit the same curb from 3 to 12.5 tons since 1989. So no adapter curb required. Now, it's a huge competitive advantage from a contractor's end of it and a huge time saver on the contractor's part of it. So you get savings in install, and you also get savings in energy. Now, what we often see happening is people want to change out equipment for a new high-efficiency rooftop. So what they do is they put a curb adapter on, and then they put this high-efficiency rooftop on there. Well, what they're not seeing is that when they put this curb adapter on there, they gain about 0.25 to 0.5 inches of static drop through that curb adapter. Well, when you include static drop, that equals brake horsepower. When you add brake horsepower, that equals energy. So a lot of times we're putting a higher efficiency unit on board, but the net result of that system probably isn't much greater than the old system because we just added pressure drop to the system itself. So since we have no curb adapter transitions in here, we basically feel this is the best fit from a savings of install and an energy standpoint to the end user. Rooftop series, we basically have multiple high efficiency models, standard efficiency models, gas electric, heat pump, Puron, 2010 Energy Star compliant CEE Tier 2 models. One of the things that we did from the rooftop series is we basically went out to our contractor base, and we pulled them. They came to the factory, they kicked the tires, they told us what they liked about the old unit, what they didn't like about the old unit, and that's how they came up with the new 48 TC and HC design unit that fits on the old curb. And what they looked for is ease of installation, they looked at ease of maintenance, reliable operation, and then ease of selection with our rooftop builder selection program. So we have reliable operation with Puron refrigerant design from the bottom up with Puron. From the maintenance standpoint, we have a new cabinet design, which we'll go over here. So from a product offering standpoint, we have a three-tier approach, just like we had back in, basically last year with our R22 models. Now we have our 48TC, which is our entry-level unit, up to 3 to 12 and 25 tons. We have our 48HC unit line, which basically right now is up to 10 tons available right now, and that 12.5 to 25 tons will be out shortly. And then what we call our special applications unit, which is our high-efficiency Centurion unit. It's basically got your slide-out chassis, your hinged access doors. It gives you the ability to put a variable speed drive on the unit, which is digital scroll in the PD unit. It allows you to put an energy recovery unit, which is the PG or PM unit with ENERGYX on there, which we'll go over in a bit also. So we go to a market in a three-tier strategy. The key thing that we're looking at, and we spoke about this earlier about the curb adapters, 3 through 6 tons, we fit units dating back to 1989. The DJ, HJ, LJ, TJ, HE, TM units out there, we basically are a direct fit. And when we say direct fit, we basically have the same gas connection, we have the same electrical connection. So they take the old unit off, they put the new unit on, the gas connection lines up exactly where it used to be, the electrical connections are exactly where it used to be. 7.5 to 12.5 tons, same exact story. The 15 to 25 tons, if everybody's familiar with our old TJ, TM unit, DP unit style units, basically we can only get so much efficiency out of that footprint. Now what we did is we basically designed a new platform, 15 to 25 tons. Since we couldn't fit on our old curb, what we did is we tried to match someone else's curb in the marketplace. And what we did is we matched that unit to fit the old Train Voyager curbs. So we could take 15 to 25 tons and put that unit right on an old Train Voyager curb from 15 to 25 tons. And we have basically a conversion chart from basically old model numbers to the carrier models to tell you exactly it makes sure it actually fits in there. So. Standard features, scroll compressors, low high pressure switches, many new factory installed options, no script screw technology, which I'll show you in a second, non-corrosive condensate pans, which is a standard, fixed metering devices on the standard efficiency models, and TXVs on the 48HC high efficiency models. Easy access door panel, larger centralized control box, command center terminal board, flexible high performance belt drive fans, and then we have a 75 VA transformer with a circuit breaker built in. When you look at the easy access panels here, we have a door handle in there right there. That was one of the feedback pieces we got from the contractors, and that was a nice option that they were offering. So no strip screws. The feedback that we got from the contractor base is the fact that they didn't want to see the old units basically stripped in the metal after they were taken off and on a couple times. Now we have a no strip screw collar factory mounted on these units. Command center, nice and easy, clean points of contact from a control board standpoint. Easy access gauge ports, so you can see here the gauge port access right over in this area on the rooftop unit. You can hang your gauges right outside the unit, okay? Accurate refrigerant pressures, reading with the panels on, that's the key pieces. Obviously it's very tough for you to get an accurate reading when the panel is off, so you hang your gauges and then basically you can read it with the panels on. Warranties that you're looking at. Compressors, 3 to 25 tons, standard warranty is 5 years. Aluminum gas heat exchanger standard warranty is 10 years. Stainless steel gas heat exchanger 15, electric heat 5. Our Novation condenser coils standard is 3-year warranty. Everyone else in the industry is typically 1, so that's a huge benefit for us, and all the other parts are 1 year. New large open control box. You can see here we can actually fit in this design. You have your command center terminal board, the 75 VA transformer, your gas controller, and then here is if you have some sort of communication over to an existing building automation system or a new building automation system, we have our RTU MP controller, which we'll go over in a second also. New larger control box, 15 to 25 tons. It gives you lots of open design and open space for design. Hinged access panels, full unit height. Gas heat design, we do offer the induced draft design, prevents carbon monoxide from entering the conditioned space if a heat exchanger fails. So it's going to basically go to the atmosphere. 3 to 12.5 ton utilize the same heat sizes up to with 3 sizes per ton. And then 15 to 25 also gives you 3 sizes per ton, 3 sizes of gas heat, 15 to 25 tons. So older models, what we used to have is we basically had 15 to 25. We used to give you 2 options of heat. Now we're giving you 3 options of heat. We're giving you a lower heat option, 220. Then we're going to the higher efficiency, a higher heat option, which is 310. And then we're going to the 400 if you need that also. Let me just check to see if we have any questions. None at this point. Nope. And you see here in 3 through 25, again, you see every one of the options has 3 heat offerings minus the 3-ton unit, which we offer a low and a medium gas-fired heat option at the 3-ton offering. Factory installed economizers. We have the multi-protocol controller so we can integrate to someone else's control system. The convenience outlets, the stainless steel heat exchangers, non-fused disconnects, all the very similar things. Humidizer, which we'll go over here in a second also. 2-position motorized dampers, smoke detectors, CO2 sensors, hail guards, coated coils if you need it, and we offer centrifugal power exhaust 15 to 25 tons as a factory installed option. So we're going to talk a little bit about humidizer, and this is our reheat coil option, which offers 3 modes of operation, which in the marketplace no one else offers. The key piece to this is we have 3 modes. Everyone in the industry has 2 modes. We offer 3 modes. We have the normal mode, which calls for cooling only, used when a high degree of cooling is required, such as a design day. We have our subcooling mode, which requires a call for cooling with a high space humidity, and basically it'll improve your latent capacity by up to 40%. And then what we have that no one else offers, which is the gas heat reheat mode, which provides neutral air, 72 to 75 degree air off the unit when you require dehumidification with no call for cooling. So what this does is it allows you no overcooling, and it allows you to keep your unit running and maintain precise humidity in the space itself. So when you look at it from an overall schematic standpoint, this is the 3 modes again: normal mode, subcooling mode, and gas heat mode. And down here I have the old models that used to be on, but this is basically all on our new 48 TCs and PG units. So normal mode operation, here's a schematic of our evaporator coil, compressor, condenser coil, and humidizer coil itself. So when we're in normal mode, we'll have refrigerant flowing, and we'll have the RH2X valve will be closed, and the RHX valve will be closed, and it will be just going through a normal standard operation for cooling itself. This is our normal operation. When we go into subcooling mode, what happens at this point is we have our RH2X valve closed, and we then open up RH1, and then it basically goes through a secondary coil, which then basically allows us to get to that 40% extra latent capacity in the system itself. And the key piece is when we have through-circuited units from 7.5 tons plus, we have 2 of these coils. So whereas a lot of people offer only 1 of these coils on a 2-circuited unit, we offer 2 of them. Okay, so that we can get more latent capacity out of these units than typical manufacturer. The last mode, which is basically the hot gas reheat, the neutral air mode, is when we're basically taking and we're opening up that RH2X valve, and then we're basically going through and we're reheating the air further up to a neutral air requirement. So, Okay, and this can basically be used with any of our typical commercial thermostats or a humidistat in the system also. Rooftop MP basically works with over 70% of all control systems. It's factory installed. It talks BACnet, Modbus, Johnson N2, Echelon LawnWorks. The lawn system is basically a chip that's added on in the field. Everything else is basically just dip switch compatible. So all you do is basically you'd use the dip switch to configure which one you want. You want to talk BACnet, Modbus, Johnson N2. You flip the dip switches in the field, and then you could talk to the existing or new commercial control system itself. So 15 to 25 ton rooftop features. One of the key things when we talked about entering into this market is we needed to basically have a dedicated horizontal supply and return unit. For those who are used to the Carrier rooftops from 15 to 25 tons, our old design, we needed a curb that allowed us to go side supply and return on the unit itself. Now this new unit, we have side supply and return off the rooftop itself. So from 3 to 100 tons, we can do side supply and return on our package units now. We don't need a curb to do this. One of our other competitors, Lennox, when they actually came up with their new unit, their high efficiency now models, they require a curb to do side discharge. We realized that was not a great design. That's why we got rid of it, and that's why we're now going to a dedicated horizontal supply unit right off the rooftop unit itself. That's a key piece. Fits, like we mentioned earlier, fits past train Voyager units. Here's the slide that basically kind of talks about what we used to do, which is the bottom piece, an over and under design. Now we have our supply and return built right into the unit itself. Here's the lineup of where we're at. From a train unit to a carrier unit and where it lines up. The red is the train, the blue is the carrier lineup. We have the same gas connection side right there. You see the train inlet right there, the carrier gas side right there. The electrical connection is right there with, actually it's just on the side of it versus the train unit, so it should not be a very much of additional cost to do any electrical work on that either. So we fit on those old train curbs, 15 to 25 tons. Talk to your salesperson, send an email over to me if you have any questions on that. We could tell you the exact model number it can replace directly onto. 48 PD, this is for special applications unit. The key thing here is a variable tonnage unit from 5 to 1 ton. So what it does is it used a variable speed drive which can vary the fan speed to 20 to 100%, and then it's got a digital scroll compressor that basically varies it from 15 to 100%. And what we find here is basically the fan will control the temperature and the VFD. So basically we're basically controlling both of these things at the same time for a typical space. So very, very simple. Single zone VAV. It's not a standard VAV unit with boxes on it. It's a single zone VAV. So able to provide precise cooling to the space itself. Energy savings, more consistent space temperature. They say 40% energy savings. I'm going to show you here in a bit. Reduced indoor fan noise is available. So anything 5 tons and under, basically this unit will basically fit right. We have it. It comes in 4 and 5 tons right now. We have a lot of success stories out in the marketplace. Here is a job that let me just. Here is a job where we basically have. We're looking at a 10 SEER constant volume unit, a 15 SEER constant volume unit, and then we have our 48 PD, all in a building that has the same exposures from a cooling standpoint. And you can see here the hourly KW, where the green line is, where the red line is, and the blue line is for this building. Now this is just absolutely, this is basically the unit indoor fan motor on the system itself. When you look at the energy use from this, you see that typically, on average, about 30% of the energy of a package unit is spent for basically the indoor fan system. With this 48 PD unit, you can see that basically 9% of the energy for the unit was spent on indoor fan energy. the key piece is, so if you look at this and you're comparing this 48 PD unit, which on paper, which on paper is rated at about 50, I think it's just is at 15 SEER. So if you compare it to a standard 15 SEER unit out there, what you're not going to understand is this is actually 46% more efficient than a constant volume 15 SEER unit in the marketplace. And this was basically an energy result audit that we did on a building, on a school in Phoenix. So what they have is you have 53% energy savings over a standard 10 SEER unit. So absolutely huge energy efficiencies by basically able to modulate the indoor fan itself. Next, we're going to talk about the Centurion ENERGYX unit. This is a factory-installed energy recovery wheel on the roof, on the Carrier 48 PG PM style rooftop itself. The key piece is, again, factory-installed energy recovery ventilator. Enthalpy wheel pre-cools, dehumidifies, preheats ventilation air prior to entering the evaporator coil. What the thing you have to look at is you have to consider a wheel as an extra stage of compression and an extra stage of heat. So if you have a traditional 2 through 5 ton unit, 2 through 6 ton unit, you now have basically 3 modes of cooling. You have economizer, you have energy recovery wheel, and you have first stage of cooling. If you go above that, 7.5 to 25 tons, now you have 4 stages of cooling itself. On the heating side, we're giving you an extra stage with the wheel itself. Okay. Energy story on the wheel, you have a huge energy payback on wheels. Typically in the Chicagoland market, we see if you have over 30% of outside air, we can give you a payback story with the wheel itself. So benefits: downsize the base unit because we're recovering some of the outside air, expand the application range, extra cooling, dehumidification. We can do economizer, 100% outside air economizer. What they call, we have basically a system efficiencies up to 21 EER with this wheel itself. When you take into account the wheel and you basically, the unit itself, we're at 21 EER. No one can touch that in the industry. Better factory installation, so we have an ETL single point electrical unit on the unit itself. We reduce field labor for secondary units being installed in conjunction with your unit. Factory wired, everything goes to a Carrier ComfortLink control device from an overall management standpoint. So you have 2 direct drive wheels, two direct drive fans inside that ERV controlling the exhaust air and the outside air coming into the unit itself. It's a fantastic option. So if you look at this option here, this job here we're looking at, we have the requirements of 4,000 CFM. They require 2,000 CFM of ventilation here. Outside air temperatures are 95 to 77. What we're at is you have an entering air temperature of 85, 70 at the coil itself, leaving air temperature of 55, 53. So these are the requirements. If let's say we looked at this and we're going to use a 15-ton 48 PMB unit, and we're going to oversize the unit itself, and we're going to run it at the lowest CFM possible to do that 2,000 CFM. You can see here we're going to do it, but we're going to oversize the unit to do it. And basically we're going to have a leaving air temperature of 58 to 57 degrees. When you add your motor heat in there, you're going to be at 60 degrees or 61 degrees on the unit also, and you're at 12 EER. Let's say if we use a standard 48 PG 10-ton unit, now what we're doing is we are looking at our high temperature, looking at the temperature leaving the evaporator coil, 60 to 61, and we're not quite obviously meeting the total cooling load of the system either, just like we weren't in the 15-ton unit. Now let's look at the 48 PG with ENERGYX. We're going to use a 12.5-ton unit, so we're going to deliver the 4,000 CFM required, the 2,000 CFM of ventilation air. We have our outside air temperature. We're going to basically hit our evaporator at 78.66, and we're going to leave that unit at 55.53. So we're doing proper dehumidification and cooling in the system itself. We're meeting the capacity. Oh yeah, and by the way, we're at 16 EER as a combined efficiency factor on the system itself. So huge energy savings, plus the comfort part of it. You add an extra stage of cooling, you add an extra stage of heating. Very simple, compact design from 3 to 25 tons. It's a fantastic option on the 48 PG unit. We can do energy analysis for you on it to show you the payback on it. So I guess at that point, if anybody has any questions, I probably rattled pretty quickly through that. If anybody has any questions, please let me know. And we can, here, let me see. It looks like I have a question. Are the 48 PGs currently available? That was one question. Yes, they are currently available. The 48 PG has actually been available in that. Let me take that back here. The 48 PG is available up to 12.5 tons, 15 tons plus. It goes up to the 48 PM. The 48 PM is basically the same as the 48 PG, except for the fact that the PM has a microchannel coil, where the PG has a copper tube aluminum fin coil. Okay. So any other questions out there? Oops, here, one more question. Can the 48 PD use with an infinity zone damper system? It does not talk infinity. It does not talk with the infinity system itself. So what I would, if you have any questions on talking to an infinity zone damper system, what I would probably, if you have a rooftop application and you want to talk infinity, there is an infinity line of rooftops that we can use for that. So what I would recommend you do is you can send an email over to me, or talk to your salesperson, ask them about that product itself. Let's see. I think that is about it. I don't see any other questions. Anybody else have any questions out there? Okay. All right. Thank you, everybody. If you have any questions, you can always contact me. I think my contact information is attached. If not, my email address is mike.smid@tecmungo at tecmungo.com, mike.smid@tecmungo.com. My cell phone number is 847-630-7867, 847-630-7867. Okay. Thank you very much, and have a great day.